Sorry about that, I did something wrong again. This has now become a two-part video. What I've done is I've copied target B here, and rotate it -120 and flip it vertically so that it looks, well, I didn't do a great job there, did I? It looks more like there. Matches up pretty nice. And looking at our retrosynthesis, there's our target. The new bond is to 1, which bonds to 2, which has a double bond to 3. Here's where our spatially challenged minds, especially those like mine, come into context. The O used to be bonded to 3. I'm basing it on this. And 3 is down here. So let's try, and then we can redraw it so it looks more like a real molecule. The O used to have a bond down to there. The double bond wasn't there. It used to be here. This is the new bond. I'm putting the numbers on. Don't worry, we'll clean things up in a second. 3 is bonded to 2. It's bonded to 1. And I will tidy that up. It looks a little better. And the new bond here was made by heating this species here, and the bond went here to here, and this broke, and we made our product. Remember, this used to be a phenol that had a new bond made here to make an ether. So before it was this ether. This would have been a traditional SN2, except it's intramolecular, so even then it's not a traditional SN2. You got an O- attacking a carbon with a leaving group. That would have to be like a bromine or a chlorine. We used bromine last time, chlorine this time. And that should be an O, not an O. An O-, not an OH. And we make those from alcohols, don't we? Before we move on, we're almost finished. We didn't finish the Claisen here. Didn't need chemicals, we needed heat. Or else you don't get a Claisen. I do suspect mixing this with a tertiary allylic alkyl halide with SN1 product would predominate. Forward synthesis on this one. You can use KOH in the first step. That would make the base here. And that would close immediately to this ether here. Which upon heating should give us our target. And maybe you want to see how that Claisen works, because that one's not straightforward. I had trouble visualizing it myself when we did this. That's not a retro. We're doing synthesis now. KOH gives that. This would be an intermediate. It would probably immediately close on its own. We're going to need heat. We got some heat right here. And that's going to give this, which is our target. Let's put it over here. So we can get a box around everything. Before we shade in our box, let's do the arrows that make this become this. The arrows are in right here. The CO breaks and becomes a carbonyl. Yep, sorry. CO here breaks and becomes carbonyl. This then attacks over here, and the dreaded crossing arrows help this visualization not at all. And we have that. So let's, shades of pink for clarity here. It's underneath, but let's make sure we know they're crossing. There we go. Do they follow the arrows that we had up here? I'm pretty sure they do. You get a ketone, which we didn't draw, which is going to tautomerize to our final target here. And that ends this problem. Let's just tidy it up and say goodbye. We see that carbon 3 is no longer bonded to O. 3 is by itself. 3 is double bonded to 2. 2 has an isopropyl. 2 is connected to 1. And 1 has the new bond based on this arrow here to the ortho position of the phenol. And that seems to fit the bill. Ketone tautomerized to alcohol. And there you have it. We solved problem 21.4.5. I hope this video helped you out, and I encourage you to suggest any other problems, textbook or OWL, or even practice exams, especially practice exams. We will cover those together in videos. Until then, goodbye.